So we will implement perceptron training rule on this AND gate where the inputs are A and B and the output is A and B. So which is the logical AND symbol, and now the output will be true or 1 only when both the inputs A and B are 1. Only in this case the output will be 1. For all the cases when not both A and B are 1, then the output would be 0. So there are 4 training examples that we need to work on and we need to apply the perceptron training rule for. So we will assume we have the inputs. The next thing that we require, these are the inputs, this is the output, and the next thing that we require is a weight. Weight means the weights corresponding to inputs A and B, and another thing that we require is the bias. Bias value is the minimum threshold value. So for now let's assume that the threshold value is 1. All right, and we have something which is called as learning rate, which is n, which is equal to 0.5. So I'll discuss that also. Now let's see the assumption. So we have assumed that the weight of input A is 1.2 and W2, which is the weight of input B, that is 0.6. We are assuming these weights. We are taking the threshold value as 1 and the learning rate n is equal to 0.5. The learning rate means the rate at which the examples will learn the values. These training samples will learn the value. So you don't have to get into detailing of what is learning rate for now. We will take it an average, which is 0.5. We can take it 0.1 also, 0.2 also, but on an average learning rate of 0.5 is good enough. Okay, so now we move to the values that we have to calculate, which is Wi into Xi. All right, so how do we calculate Wi Xi? So Wi are the weights and Xi are the values which are the inputs. So we have two basic inputs. One input is the input A and second input is the input B. For A we have these inputs 0 0 1 1. For B we have these inputs, and for all of these values of A the weight to be taken is 1.2, and for all of these values of B the weight to be taken is 0.6. So line by line we will keep on applying these weight values for the first training sample, then for the second training sample, then third, and then fourth. So what is the weight? 0 into any weight would be 0. 0 into any weight would be 0. So we will get A equal to 0 and B equal to 0, and the target is also 0. So Wi Xi would be 0 into 1.2 plus 0 into 0.6. So the answer will be 0. So the target was 0 and this is the actual output, which is also 0. And since the actual output is equal to the target output, no change required. No change is required to the weight. Okay. Now we move to the next training example. The next training example is the second row. So this is the next training sample, and for this training sample again we will do 0 into 1.2 plus 1 into 0.6. So the target is 0, but what we get is 0.6. And now since we have a function, that function is basically related to the threshold value. If the threshold value is not greater than 1, the output to be taken as 0. So the function is if the actual output is not greater than 1, all right, then it is 0. If it is greater than 1, then the output could be 1. All right, So we will work on this. Now we got 0.6. 0.6 will be considered as 0 because the threshold value is 1. Since it is less than the threshold, the output will be considered as 0. If it would have been greater than 1, then the output would be taken as 1. Alright. So now the target output and the actual output is same in the second case also. So in this case also, the target output is equal to the actual output, so we do not make any changes or modification to the weight. This one is the case 1 where we get the actual output as 0 only. This is case 2 where we get the actual output as 0.6. But since 0.6 is not greater than 1, so the output is 0 only. Here also, since 0.6 is not greater than 1, so the output is 0 only. Since actual output and target output are same, no modification of weight. Now let's move to the training sample 3. So for this third training sample, 1 into 1.2 plus 0 into 0.6. So again, the answer would be 1.2. Now, is it greater than the threshold value 1? Yes. Since it is greater than the threshold value, the output would not be 0. The output would be 1. The target output was this. The actual output is this. Now there's a difference between the target and the actual output. So the weights need to be changed. So how do we change the weight? There's a formula that I discussed earlier in the previous videos. If you have not seen the previous videos, please go and check out the previous videos. So now what you have to do, you have to update the weights based on a formula, and that formula is Wi is equal to Wi plus n into t minus o into xi. So Wi means weight for input I would be equal to, so this one is new weight. New weight for input I would be equal to the old weight of I, input I, plus n. N is the learning rate which we have taken 0.5, and this is the target value, and this is the actual output t minus o into the actual input. So what was the value of input here? The value of input for A is 1. The value of input for B is 0. So first we calculate the weight for A. So value of A is 1. All right. So what is the weight that was there for input 1? 1.2. So this is 1.2, the old weight, plus the learning rate. What is the target? Target was 0. So this was the target value. The output that came was 1. So 0 minus 1. And what is the input? 1. So what do we have? 1.2 plus 0.5 into minus 1. So 0.5 into minus 1 becomes minus 0.5. Minus 0.5 into 1 becomes minus 0.5 again. So 1.2 minus 0.5, we get 0.7 as the new weight. So this one is a new weight. Similarly, we take the value for the second input. The second input is B. Here the input is 0 and W2 will be the old weight, which is 0.6, plus the learning rate, which is 0.5, the target value, which is 0, the actual value that came up, which is minus 1, multiplied by the input. What is the input? B. So all of this multiplied by 0 will be 0. So the old weight and new weight remains the same. So W2 is the new weight, and already it was 0.6. Now again it is 0.6. So weight 1 has changed to 0.7 and weight 2 has remained same, 0.6. Now taking these new values, we have to restart from the first training example, then second, then third, then fourth. So we have to apply all this again now. Am I clear with this? So now taking this value of W1 as 0.7, W2 as 0.6, threshold as 1, learning rate as 0.5, I will apply it again to examples 1, 2, 3, 4. These 4 training samples will have to be worked upon again. So for first training, we have 0 into weight 1, 0 into weight 2. In दोनों को add करेंगे, we'll add these two and we'll get the target output as 0. So this was the target output and this is the actual output. So it is same. Since they are same and this actual output is not greater than 1, so the output is 0 only. All right. Then we move to the second training example. So for the second training example, we have the input as 0 and input of B as 1. So 0 multiplied by weight 1 plus 1 multiplied by weight 2. So we will get 1 into 0.6, which is 0.6. Since it is not greater than 1, the output would be 0. So the target outputs was 0. The actual output is 0. So no change. Then we move to the third. The third training example shows the input as 1 for A and 0 for B. Now we will do WIXI, which is equal to 1 into 0.7 plus 0 into 0.6. So what do we get? 1 into 0.7 plus 0 into 0.6. So this becomes 0. We are left with 0.7. The target was 0. This is the target. And the threshold is 1. Since this actual output is less than threshold, the output would be 0. So now the target output and the actual output are same. So no change, no modification in weights. We are left only with the last example. Let's hope it gets finished without any modification. We have to modify only when the target and the actual are not same. If they are same, we don't have to modify the weights. So let's see what happens next. So we move to the next one. We have the fourth training sample, and in the fourth training sample, we are just applying for A and B. A is equal to 1, B is equal to 1 and target is equal to 1. So for this, we have 1 into weight 1 plus 1 into weight 2. So the answer becomes 1.3. Since it is greater than the threshold value, which is 1, so we'll get the output as 1. The target was 1. The actual output is 1. So in any case, we do not need to update the weights. Since these new weights have been used along with the threshold value 1 and learning rate 0.5, and we have classified all the training samples. So these are the actual weights which could be used for the AND gate for the input A and B. So this is the actual diagram that you should see and that you can write down for the actual values of weight, with the weight value 0.7 and the weight value 0.6 for the inputs A and B. So we get the weighted sum, we get the theta value, which is the activation function, and then we get the output. So for AND gate, the weight associated with A is 0.7 and the weight associated for B is 0.6. All right, I hope you have understood this implementation of AND gate using perceptron algorithm. If you have understood, please like and subscribe my channel and share the videos with all your friends who are in IT and who require computer sessions. Thank you so much. Have a nice day.